take a moment here and say hello. Hello today. It's a wonderful evening. Today, I wanted to talk a little bit. I've been going over some of my old notes. I had the opportunity. It was a really neat opportunity to take a class when I was in college about scientific theory, and it wasn't specifically about scientific theory. It was it's eluding me right now. What's the word? It was an ethics class, but focused on science, and it was a lot about how science should be, how it's meant to be done, and how it's not done, and it is done, and different things. But today I wanted to talk about basically the process, because the thing is, you see a lot of different ideas and a lot of scientific consensus, and everybody thinks that they know exactly what's going on. I've been fascinated lately. Been learning about how reconnected successfully. Well, hopefully that worked out all right. I don't know if that. I'll just wait until it starts to pick up again. Sorry about that, but that's life. There we go. So, anyways, I've been learning about just kind of doing a little bit of a dive into optics, and not like optics of how a company looks to the public and that kind of stuff, but actual optical theory. And so Galileo, he designed a telescope that he used, and he would look at the moon, and he would say, "Oh, look, you can see these craters on the moon." And some people would be like, "I don't know if I can see it. I'm not sure what that is." And other people like, "Oh, I see it. I definitely see it." And Galileo would take his telescope to these parties where the rich were, and he would kind of vaunt it and use it as a tool to prove his point of view. Well, the interesting thing is, there wasn't any optical theory at that point. People didn't talk about the way that our eyes work and how we see things. And because there wasn't optical theory, a lot of the assumptions that Galileo made were assumptions that he didn't know any different of what he's seeing or what he's looking at. And so I wanted to break down clearly what is in the scientific method, what exactly we're talking about. So, there are 3 key things that you need before you can make a prediction and test that prediction. You have your theory, so that's what you think is going to happen. You have your EC. What was EC again? I just changed the page, and so using my notes. Experimental conditions. There we go. You have your theory, you have your experimental conditions, and you have your assumptions. So theory is, okay, it's something that you can test. You can actually make a test on that theory. If this happens, then this should happen. Your experimental conditions are the factors that come into play to make that theory work. The factors that come into play, like if you're doing a test, and it will interact differently when you're at sea level versus when you're up on the top of a mountain. That's an experimental condition, because you can have it at sea level in one test, and you can have it up in a mountain in a different test, and you can change those experimental conditions to test validly your theory. And assumptions is everything else that you don't know. That's everything else. It's an assumption. You assume that there's nothing else going on that you don't understand. If there's something else going on that you don't understand, that would be an assumption that is wrong. That, okay, I made an assumption about this, and the assumptions aren't explicit. You don't say, "Oh, I assume that if this happens, then this is how this is working. If this happens, this is how this is working. If this happens." Assumptions don't work like that. Assumptions are the things you don't know. So you have your theory of what you think the principle is that you want to prove. Okay, if this happens, then this. If this happens, then this. You have your experimental conditions, the things that change, your variables in the test. And then you have your assumptions, is everything else that you don't know. Those three things have to come together. And when those three things come together, you can make a prediction on what should happen when you test. Okay? If you can't make that prediction, then your science is, it's not actual science, it's conjecture. It's making assumptions. It's taking what you see and fitting it to the paradigm you want it to be in. And so that's why you get into this battle between true science and pseudoscience. Things like true science would be in your chemistries, in your engineering, in your a lot of the things that you can very clearly test yes or no. A pseudoscience would be things like psychology, things like sociology, things like geology. Those are things that, okay, we observe and we make assessments, but we don't really have a way to test these things, because any tests we do are going to be subject to who we do them on, or any tests we do, there's just too much going on that you don't, where it's not developed to the point where you can actually know for sure. And that in saying that in itself, that's one of those things that's like, you can't know for sure, like with science, and I'll explain why. Okay, so in science, there are two main ways that they do testing. There's through deduction and through induction. And they're very similar. There's an asymmetry there that's really pretty, but I guess there's more than two ways that they do testing. But anyways, there are two really good forms that have been accepted throughout the years by a lot of the scientific community, and everything I say there is like grating on me a little bit, because when I say accepted through the scientific community, that's like basically saying, oh, that's a vote, or that's what people do. And getting into, okay, let's just focus on like what Karl Popper, his belief on the scientific method, and he was the one that came up with. He's the one that really pushed hard for the scientific method as I'm presenting it right now. So you have the theory, the experimental conditions, and the assumptions. Okay, once you have those three things, the combination of those three things allow you to make a prediction that you can test. When you test that prediction, one of two things can happen. You can either be right or you can be wrong. Now, in science, a lot of the testing that they do is through falsification. They, instead of saying the theory, I believe this will happen, they say, I believe this won't happen. And there's a reason they do that, is because it's easier to rule out things that are impossible than to prove that your explanation fits why it's happening. Because to rule out something that's possible, you have to take your theory, you have to take your experimental conditions and the assumptions, and you deliberately make something not true. You deliberately say, okay, because I think that the theory is this way, I'm going to say this should not work in this theory's purview, in this theory's the way that it works. This theory should show that it's wrong. And when you take your experimental conditions, you can deliberately make something that shouldn't be possible. There is still the possibility of those assumptions, those things that you don't know you don't know what you don't know, and that causes the theory to be true or false, not knowing why. But it's much more confident building when you can say, okay, because of these things, it wasn't true. Now, the other way is not as sound, and that's why most science is used through falsification. Is, okay, here's my theory, here's my experimental conditions, and my assumptions. I think that this is going to happen, and then you do it, and it happens. There's far more likelihood that the assumptions are going to interfere with what's happening simply because you don't know. Now, why am I going off on that? Going back to optics, there was a lot that Galileo was using that there was no scientific theory behind optics. There was no theory of optics. There's no theory of how light works and how we see and how we. I mean, they had observations, but it wasn't formulated in a way that Galileo was doing a lot of. From what I remember and what I understand, he was doing a lot of trial and error, where he was just, if I take these mirrors and use these magnifying glasses, it lets me see further, and it was exploratory, which was it's needed, but because you're exploratory, you're using a lot of assumptions that you don't even realize are assumptions, because the field is new. The field is brand new. One of the things that makes that interesting to me, though, is we still don't have a huge. I mean, there is a field of optics. I mean, that is used for, like, in medicine, your optometrists. They deal with this completely a ton, but we're doing things with optics where we're using electron magnets that are we're magnifying. We're seeing particles that are so small, and we're making assumptions about what we're seeing, but yet we don't necessarily know. We don't have solid ways of, we don't know the groundwork that we're working with. We don't know a lot of things that we're working with, and because we simply don't know the things that we don't know, it makes it very it's very easy for us to make assumptions and come to a scientific consensus, but yet that consensus to be not valid, or not even close to correct. And the most interesting thing I think about this is how, when you get into the public sphere, where people are saying, sending out different opinions and saying, like, they paint the. I mean, just for instance, Owen's been talking a lot about the moon, and he's been talking a lot about the shape of the Earth, and whether it's a sphere, whether it's a realm, whether it's a flat, whether it's, like, there's so many things that we have assumptions on, and our assumptions, they propagate through different parts of life. They propagate through different sciences. There's a lot of bleed over into different parts of life that aren't related, that wouldn't normally be related. And the thing that is really interesting and sad is that people don't think of things from science in a way that is intellectually honest. They think that science comes up with a truth, or it comes up with a something that's a fact, and the truth is, science has no business in truth. The purpose of science, and this is one of those things that, like, if I remember right, Popper was really focused on, science is, the purpose is to find the truth. But most of the people that came after Popper, several of the other philosophers of science, philosophy, that was the word. It was a philosophy of science class, not an ethics. Anyways, most people think that that's too, what's the right word? Too brazen, too bold. No, it's a hard claim to say that you know truth, because that in any assumption, in any theory that we come up with, you don't know the things that you don't know. So it's more accurate to say that science is useful in predicting what's going to happen under a certain circumstance. It's very useful. That's what science is meant to do. It's meant to help us understand the cause, how things happen in the world around us, and specifically in phenomena that we don't understand, whether that's lightning, whether that's tornadoes, whether that's earthquakes, whether that's those are all natural, but whether that's how water turns into ice and then boils, and how these are things that help us understand how the world works, but it's not necessarily truth, because the only way that we can the only way that we can get a firm handle on these observations is by observing. And in the very act of us observing, we don't know the things that are filled in. For instance, I mean, I'm just thinking of our eyes. We see very, very, very high resolution with our eyes, but that section that we see that's very high resolution is our focal points. The very small part of what you're seeing is, from the way that the way that I've understood it, is high resolution, and our peripheral vision is very, very low resolution, and our brain fills in the gaps. It fills in the things that it objectifies the picture that our eye sees. And so because we take that high resolution and we move it around from here to here to here to here to here, often our mind can map out, okay, there's a monitor there, there's a microphone here, and we keep that in our mind. And so when we see that low resolution, we don't need to reprocess what is it, we just fill in the picture. And where's I going with that? Well, basically the thing is, why science isn't good at finding truth is because we don't know where it stops. We don't know what happens. We don't know, like, we're just observing the world around us, but we can't, the whole causation is not causation. What is it? Correlation is not causation. Just because something happens in connection to something else does not mean that it's caused the way that we think it is. And it doesn't mean it's not, but it also doesn't mean it is. There's a lot of things that we don't understand, but yet we need to operate in a world in a way that we think we do. And that's one of the things that I found so deep and so fascinating about how Owen has really dug into the moon landing and dug into a lot of these fringe conspiracy theories that you would think, growing up, you would think that they were nuts. Well, at least I did. Like, I remember some people saying when I was little that we didn't land on the moon and stuff, and I thought that they were joking. I never thought that people seriously didn't think we landed on the moon, just because everybody I knew talked about it. Everybody knows it. And same with having the fact that, the Earth's not the Earth. We're on a spinning globe. The model of the Earth that we use, and the solar system, and how it's a globe spinning and stuff, and there's little, because we hear something and we stop questioning, we stop asking how this works and why this works, and it dumbs down our sense of curiosity. We no longer look for those assumptions. We no longer look for those things that what is it that we're actually giving up? What is it that we're giving up? And I've really enjoyed how Owens made that connection of a lot of these things that we believe naturally from just society and what society has taught us. They detract from God. They take it so that they make it so that we no longer think that we're children of God. Instead, evolution is a grand example, and which has conclusively been proven false. Evolution has been proven false, but yet nobody talks about that. Nobody entertains that. People do, but most people who hear that, they think, oh, that's nuts. Those are crazy people, and it's like, well, no. Look at what we have. Look at speciation. Look at how that happens and the time frame that we have. And statistically, it's very, very, very hard to have a statistical case. I mean, not very hard. It's to the degree where it's impossible. I mean, it's to have a statistical chance change that would match what we know of what we have observed in nature. And for instance, the way that this gets blown out of the way that this gets damaging is I was in a geology class, and I had a professor that she was a great professor, but she was out for a week, and there was a student professor there that was teaching us about carbon dating. And I remember they were talking when I was young. I learned from some science magazine that the sun goes through weather changes, and whether there's solar flares, and there's things that cause it to emit radiation at different levels. And so I asked the person the way that they explained carbon dating, the way that they explained how the half-life works with the carbon, is it's affected by the radiation of the sun. That's one of the things that causes that half-life to break down. And so I asked the person, I said, well, what happens if the sun doesn't emit radiation consistently through those thousands of years that you're talking about? What does that do to carbon dating? And the student, the grad student who was teaching our class at the time, she looked at me and she said, her answer was this: haven't you ever heard of the scientific method? And she moved on. She just didn't know. She was just ignorant. And instead of acknowledging that, that's where human behavior comes into play, and scientists, being people, are susceptible as anybody else is to this fact that when you're human, you don't like to admit that you don't know things, or especially when you're the leader in a field, or the teacher, or the someone who's supposed to be an authority, and when you don't know something and someone points that out, you're like, do some hand waving and try and brush it off. But she didn't know, and it was just someone who carbon dating is supposed to be one of the most accurate ways we have to date things, because we've been able to test it for so long, relatively, and that still doesn't answer to my satisfaction. That doesn't answer the question, but there might be an answer. I'm open to them. They're having an answer, but I haven't heard it yet, And so, just because I haven't heard the answer doesn't mean there isn't one, but it also illustrates the fact that we make these assumptions and they get carried into part of the discourse, and then they get ingrained into an indoctrination. And when we're doing science, and when we're using science to make lasting decisions, that indoctrination is very damaging. It's very it's destroys the credibility of what we're doing, and not necessarily just the credibility. It can be counterproductive to what we're trying to accomplish. I didn't get much into induction and deduction, but I don't think I need to right now. The thing that I wanted to get back into was how this idea that we're just dust. We're just dust in that's cosmically randomly become through evolution, and we're just a statistical coincidence is one of the things that just takes us away from God, and that's a big deal. That's an understatement, but I think that it's interesting how one of the simplest truths that we can understand is that we are God's children, that He's our Father, our Heavenly Father, and the adversary is always trying to discredit and belittle and make that not seem plausible and possible. And when you look at a lot of the scientific theory that has been accepted as strong or valid or true, a lot of it is not, I mean, people who have faith don't question their faith because of science, but people who don't know, they do. And that's where it gets damaging. The thing that I believe, and the thing that I find the most important, is obviously prayer. Is you need to get to know God. You need to pray until He answers you, and so you can have that personal experience. And that's not a scientific knowledge or not a scientific truth. It's a spiritual one. And instead of trying to fit science into instead of trying to fit what you believe into science, it allows you to believe something and then allow science to stand on its own. Science is valuable and it's neat, but it needs to stand on its own. You can't have faith in theories. It's just evidence. It's just, okay, is it happening? Do we know the things that we're predicting or not? And it's not a emotion, like a faith-driven thing, because when it becomes faith, it's in the realm of religion, and that's not scientific at all. It's meant to, or religion is fundamentally, it's spiritual, and that's why those truths that are spiritual can only be felt individually and not scientifically, because they're that personal connection with God, and they're real. Like, just because you don't have a clear way to identify, oh, if you do this and if you go here and say these prayers and do these things, then you're going to see angels, and then you're going to see... No. The biggest thing is, like, how would you expect God to answer you, you know? And then when you think of that, how would I expect God to answer me? Ask yourself, why? Why do you think He should have to do that to you? And humble yourself to listen to how He wants to talk to you. That's why when Christ taught, He said, be as a little child. So you could be humble, so you could listen and learn, and not say, oh, if God really existed, He would tell everyone everything, and so there would be no questioning. Why? Why do you think that? You know? Do you think that you know? I don't know. I know that when I pray and when I ask and when I seek, I feel Him near me. And it's not in my head. It's not... There's a case to be made for, oh, maybe it's just psychological. Maybe it's a placebo. There's a case to be made for that. But as I try and as I express kind of go through the scientific process, but on a personal level and on a private level, not on a public documented level, but as I keep praying and keep asking and keep searching for truth, you feel it. It's something that you feel in your soul, and in your mind is enlightened to it, and it's not a truth that anybody can give to you or anybody can take from you. But science is not that. Science is us taking the world that we see around us and trying to understand it so that we can use it to make it better. And that's one of the things that's beautiful about science, is it's us being able to cultivate better lives, better living, which innately I think is something from God. He wants us to grow and to be happy, and at least I think He does. Well, that's all for tonight. Rock the party.